thanks for the invite. I always feel a slight fraud here because I don't run millions of minutes through an actual service provider. But yeah, so this is about real-time data on the WebRTC data channel, which is kind of relatively obscure, but it's kind of interesting problem space. And so yeah, I'm Tim Panton. I'm the CTO at pi.pe GmbH. We wrote a little WebRTC stack for small cameras, baby monitors, that kind of thing. And what you saw at the beginning was that stack running on this device and showing you. But what's happened in actually kind of middle of the pandemic is a friend of ours rang up and said, hey, could you take that stuff and put it in race cars? And we're like, well, all right, but we can't use Wi-Fi. So I've ended up with this stack driving around racetracks at 250 kph, which introduces a bunch of interesting problems. So kind of, it's a race car camera, so it's over the driver's shoulder. And the audio and video is sent live to the pit crew at very low latency so that they can advise the driver. And in fact, we may even I have a driver driving at the moment, so I don't know whether, yeah, there we go. Can I send the sound? Well, anyway, you can hear that. I am going to need sound later maybe, so maybe we'll try and fix that. But so this is it. This guy's driving. I don't know where he is, but he's like being watched live in 5G by the pit crew and now you lot. So the so yeah, low latency. But the interesting thing about no, do I have one of those?
Probably. Yeah,
yes, cool. I still have a headphone socket.
Yeah.
Yeah, so interesting thing about this is that like they're driving at high speeds and we're using public 5G. And it's over a relatively short range. I mean, these tracks are like 5 kilometers in diameter typically. So what you see in that when you graph it is pretty rapid fluctuations in bandwidth, which are somewhat associated with the speed of the vehicle. Not tightly, but so we have to manage that rapid fluctuation in bandwidth and still get a consistent user experience. And WebRTC's got a ton of tooling for this, fortunately. Like you can do bandwidth estimation with REMB and transport-wide CC. You can set and then you can use that quickly to set how much the codec compresses. And if you lose a packet, you can send a NAC. If you lose a frame, you can send a PLI. Like I think I've talked about these things before. And if you do it quickly enough, you can compensate for the network variations. So this is, and this was the side note here, and I'm disagreeing with Lorenzo on this, it's peer-to-peer. Right? This is WebRTC done peer-to-peer rather than peer-to-server. There's no need for us to have a server in the middle, given that these both ends are very close typically. You get a much higher privacy and lower latency if you don't put a cloud server in the middle. And you get lower bandwidth costs. But in the extreme cases on a private 5G, where the camera and the viewer are both on the same cell, the video stream may never leave the cell, which is kind of nice. So we've been doing that for a while, and then an interesting thing cropped up, which was, well, maybe we could use the same technology for looking over a robot driver's shoulder. And so that the remote supervisor can watch what a robotaxi is doing remotely from their office or wherever, and maybe intervene. There's some discussion about whether that's sensible or not, or maybe just send a hint to it saying, yeah, that's an acceptable choice. Anyway, our camera works great for that, and that's what we've been working on for the last year or so. But one of the things that robotaxis have that race cars don't is LIDAR. Now, I don't know if this is going to play. Let's see. No, it didn't. That's annoying. How do I get this to play?
I'm gonna try and trick my Tesla's autopilot into running through this Wile E. Coyote painted brick wall. Because unlike other cars that use sensors like radar or LIDAR to see, Teslas famously only rely on simple optical cameras for its autopilot. Now to a human driver, while that sort of looks convincing, the image processing in our brains is advanced enough that we pick up on the minor visual inconsistencies and we wouldn't hit it. And then a car with LIDAR will of course stop because it's just using a point cloud that detects a wall without seeing the painted image at all. So while my clever ruse is no match for a human or a LIDAR sensor, question is, can I trick my Tesla into running straight through that wall? Well, as a firm believer in the scientific method, there's only one way to find out. Turns out my Tesla is less Roadrunner, more Wile E. Coyote. Wow!
So, yeah, LIDAR really is a superpower that we don't have, but we compensate by more processing, and robotaxis mostly have it, and that leads me to a problem, which is our people we're working with said, well, we'd kind of like LIDAR to come alongside the video so that the supervisor can see the LIDAR images as well. And I'm like, okay, I know nothing about this. So I bought one. This is like experimental method. I bought a LIDAR and played with it. And what we find is, and I also went and looked in the literature, and actually it turns out that most people don't send LIDAR live. They either process it locally in the AV by feeding it straight into an AI, or they upload it for training purposes into the cloud in batches. There's very little low latency LIDAR being sent around that I can see. And even what there is isn't consumed by humans, it's consumed by remote AIs. So I thought, well, you know, hey, we've got a WebRTC connection for the video, let's try and reuse that. And at this point, I have to apologize that this talk is not as far along as I thought it would be when I submitted it. Things didn't go as planned. I learned from it. Hopefully you'll learn from it. It is actually funded by an R&D, EU-funded R&D project, so it's legitimate to learn from things and for things to not entirely work. So that's kind of the point of these things. So what is LIDAR data? Well, it's not video shaped. That's the big story. It's about 2 megabits a second for a single line. That's like basically a horizontal slice. And most autonomous vehicles use like a 32-line LIDAR, so there's like a stack of, as you saw in that image in the video. And each sample is typically a kilobyte packet, which contains a narrow window of data, which an array of values and of distance and quality of the reading. And I mean, the big summary there is that that's not a WebRTC supported codec, so I can't just throw it down the RTP channel and like have anything sensible to happen when it turns up at the other end. So now this is the super high-risk demo. This is a LIDAR receiver that may or may not talk to me. There we go. So if somebody in the front wants to wave their hands, then things will start moving. So that's like all of you in like the slice roughly to the tops of your heads, lined up in neat little rows, and then you can see me moving somewhere over here. Yeah. So like that's LIDAR data rendered kind of naively, but it does, you know, kind of see the shape of the room and see where you all are and whatever. And you can, like, if I put this in it, put a hand in front, like whole sections of the audience disappear. So yeah, that's LIDAR data, and it's kind of cool. So how did I do that? Well, I realized, this is again thanks to Lorenzo, I realized that actually I should really introduce the WebRTC data channel, because a lot of you are kind of RTP, you're on that side of this diagram, and I'm now on this side. So that's the WebRTC protocol stack. All the RTP stuff happens over there, and SCTP happens over this side. So the data channel is a thin skin on top of SCTP. And actually, we're going to end up talking about SCTP quite a lot now. So what can you get from a WebRTC data channel? What does the API offer you? Multiple bidirectional streams, multiplexed over the same data path, so like over the same ports, basically. And channels, each stream or channel carries messages, and the messages can be ordered or unordered, so you can promise that they get delivered in the same order, or that they were sent in, or you can say, I don't actually care, I want to get them whenever they're ready. And you can prioritize them. Messages are either reliable or unreliable, so you can say, like, I have to get this, keep retrying forever, and like, or you can say, I don't have to get it, it would be nice, and then you can set some parameters on that, like how many retries or what the max life is. And actually, I contend that most of the inspiration for Quick came from some of these SCTP features. Now, there's a bunch of other vast differences between the two, but they're particularly around encryption and startup. But like some of the sort of benefits of SCTP have been like adopted by Quick in terms of multiplexing and stuff like that. So the next question is, like, how much bandwidth do I need for that LIDAR? Well, I said it's about 2 megabits a second, but how much do I have available is another question. Now, on the RTP side of the thing, I have transport wide CC or REMB that will give me an estimate of what the channel is, what the network is capable of delivering. Despite its like all-inclusive name, transport wide CC doesn't include the data channel. So like that doesn't help me at all. The data channels do give you a thing called back pressure, which is basically you build up some latency and it'll tell you how much latency you've built up, and you can use that as a measure of like how badly things are going. But like obviously that costs you latency and it's not super accurate. And as you saw in my diagram, there are like sudden dips in the bit rate, and then having a bunch of latency you've got to get through before you can reduce the rate doesn't help that situation. So like none of this is particularly satisfactory. So I'm trying to come up with a strategy, and I freely admit that I'm in the middle of this process rather than at the end of it. But one strategy is just to say, well, hey, the video estimate, I'm running video as well at the same time typically, I'll use the video estimate and like shave off 20% of it and give that to the data channel. I don't think that's going to work, but it's like a naive attempt, and I'll try it. The other thing you could do is just let them fight it out and see what happens. Which only works if you've got some resilience techniques to let that happen, and I don't know whether that's going to work yet. That's an experiment yet to be done. So the other thing you can do, and what video codecs do, or the other part of the story, and what video codecs do is, like they do perceptual tricks. So a video codec is like reducing the amount of data it sends to you in the least noticeable way. Like it'll blur things, or it'll notice that this person hasn't moved, and therefore it can like copy it from the last frame and stuff like that. So it does a bunch of perceptual tricks. I don't know of any that you can apply directly to LIDAR of that sort of thing. And there's a huge, like, the amount of effort that's gone into video codecs over the decades is vast, and I'm not in a position to reproduce that. But there are some interesting things. Like if your robotaxi is moving forwards, then you need a faster refresh rate in the forward direction, because that's what you're going to hit. The sides, okay, they matter, but you kind of don't care quite as much, because things aren't moving as fast towards you typically, unless you're getting T-boned at the lights, but that's another story, and that's probably not a great deal you can do about it. And so in theory, you could like do that and trim down the amount of data you're sending by prioritizing it around those parameters. And it sort of bizarrely corresponds to human vision, which is predator forward first vision, as opposed to prey, which are always looking to the side. So that sounds like a perfect solution. You're like, I'll just use 4 channels. I'll have some unreliable channels with priorities and timeouts so that I can like mix this, get this, and then I'll have a reliable channel that runs at a low rate just to make sure that I always fill in like 1 frame a second of everything. And you know, that'll work beautifully, won't it? Sadly not. And this is where we get to the IATF police. The documentation for WebRTC, the RFCs, are optimistic about the reality of what SCTP can actually do and will be and is shipped. So things like you can't set both timeout and retries. The protocol lets you set one or the other. You have to choose whether you care about timeouts or retries. And as far as I can see, nobody, and somebody will no doubt correct me and show me an implementation, but I haven't found one that I can use of priorities that are actually implemented anywhere. So that trick doesn't work. Unordered messages aren't as independent as you might think they are, because you can't interleave a small message in the middle of a big one because of the way the protocol works. Or in RFC 4960, you can't. So you have to finish the big message before you can put a small message out, which kind of undermines that. We'll probably come to that in a second. And then the final thing is that this is a design bug that's been recognized in the protocol. There's a single sequence number that everything's hooked off. And what that means is that if you can't ever have packets that you never send, otherwise this thing gets stuck, and you end up with like everything is an exceptional case, which is a bad design. So like you end up with a backlog, which is unfortunate if you have these things that you say, well, I don't care about the results. So the good news is that there are actually fixes for all of those problems, apart from the retry or timeout. There are fixes in subsequent RFCs. So there's a forward TSN, which makes partial reliability work, by saying, hey, you're never going to get these packages. It sends a message to the far side saying, these are things you'll never get, so just forget about them, and then it increments the global sequence counter to that level, and we're done. And it's actually implemented in Chrome and Safari, to my surprise, but not in my stack, because it post-dates when I wrote our SCTP stack. It is fully backwards interoperable, so our stack works against stacks that support this, and once we get round to implementing it, then we'll be happy. There's some more goodish news, which is a much more recent RFC. H260 fixes the interleaving problem by adding a new chunk, new data type basically that allows for has a sequence number sequence per message, so you can like interleave messages, which is handy. It's implemented in Chrome, not in Safari, and it's only implemented behind a field trial flag. So, and again, it's backwards compatible, and I've started to implement it in SCTP4J, which is, by the way, open source, contributions welcome, all of that. And I think there might be a URL here later. If not, email me and I'll connect you, or you can find it, actually. It's on GitHub. And priority is in the hands of the sender, so joy of joys, I can implement priority in here, and Chrome, who's receiving it, can deal with whatever I send it in whatever order I send it. That's its problem, which means that priority I'm independent on. I can do for myself. So coming back to the original questions, like how do we do bandwidth estimation? Well, actually there's no good answer to this yet. The best bet looks like L4S, and I think I talked about this maybe last year, or somewhere I talked about it, maybe it was here. So low latency, low loss, scalable throughput. L4S is, I think it's, and it basically uses two unused bits in the IP header to say network equipment that's passing a packet through sees that it's going to enqueue or delay a packet. It sets a bit in that. And then the recipient can say, hey, I can see that something on the path had to queue this before it could send it, so that we're starting to build up congestion. And then the receiver can notify the sender, and the sender can do something about that. Now, there's a nice RFC 8888, which is RTCP implementation of precisely that feedback for RTP, which is supported behind a flag in Chrome and Safari. unfortunately, there are no drafts, no active drafts about how to do the RFC 8888 thing for SCTP. So, like, although L4S looks like the right solution, there's no draft about how to use it for SCTP. There are some other ways I could abandon SCTP in the data channel and go some other route, and there are a couple of interesting paths to look at there. There's P2P Quick, which seems to have sort of stalled, partly, I think, very sadly, because Bernardo Boba, who was somewhat driving it, has died, and so, like, there's a bit of a kind of hesitation about who's going to pick that up, I think. Hopefully somebody will. And basically it creates a nice path and then runs quick over it. That's a huge oversimplification, but that's kind of what it does. And so maybe we could like take Lorenzo's type ideas and use them over that, and hopefully it emerges up into web transport as well. Then the other initiative that's happening in the W3C is a thing called RTP transport, which is sort of unbundling of the RTP layer in WebRTC such that you can, like, basically in JavaScript send your own RTP packets. And at the other end, you can receive your own RTP packets and do whatever it is you want to do with them. And that actually might be a really nice solution for this, because I can just throw my kilobyte of LIDAR data in and pretend it's RTP, and it'll come out the other end without the code, without anyone trying to decode it with a built-in codec. And so I can like do the thing that I did in the here. I can do that in JavaScript and render it. So that may actually be the right way to go. There's some kind of bits that nearly work behind flags, and there's active discussion happening, but the API is super unstable because like nobody's super clear about how low a API is going to be acceptable from a security point of view. So that's, I think, probably where we'll end up going if we don't end up fixing SCTP, which is a whole other, so like two relatively unacceptable choices. So my conclusions and proposal and ask is, like, anybody who feels like enhancing SCTP with L4S, I'll help you, right? I will do quite a lot of work with you to make that happen. But the trouble is that SCTP doesn't get you promoted, not in the way that Quick does. Quick is like, you know, gold dust on your career, and SCTP just isn't. But it is deployed everywhere, so like, you know, you make an SCTP fix and whatever it is, 6 billion browsers see it, so it's like, it's quite, and I use it, so like that's important too. So like help me by contributing PRs to SCTP for J or Google's LibDataChannel, and implement L4S explicit congestion notification in your networks. I think that's actually the point I really like to make. Those of you who run networks, just if you get a software update that allows you to enable ECN, do it. It won't cost you anything. It does like no harm, but people like me who are trying to use edge of network things will love you for it and use your networks in preference to other people's because this stuff works. So I don't know how we're doing for time, but I'm kind of happy to take questions. I'm a little bit deaf, so you'll have to shout. And otherwise, just email me or get me on Mastodon. I do consulting on open source, WebRTC, and Pipey stuff. And I'm talking tomorrow at Romana's event in the TUB in Charlottenburg, is it just? Tomorrow morning about the 5G aspects of this. I kind of avoided talking about that today, but that is a 5G modem. So, yeah.
Thank you, Tim. Thank you.
Dragos with a question.
Hey, Tim. So I was wondering if you try to use multiple streams on SCTP, and that might have been an issue. You know, on a single stream, yeah, you could get head-of-line blocking, but on multiple, you shouldn't, I hope, according to Copilot.
So Yeah, I mean, I'm definitely going to use, like you can't set different priorities on the one stream or it doesn't make sense. So I'm going to have multiple streams anyway, but you still end up backlogging on the TSN. You still have to implement the TSN thing. Otherwise, well, if you want partial reliability, so my basic problem is I want to send 30 megabits down a pipe that's not going to cope with 30 megabits. And so I have to drop things. And the question is, where do I drop them and how do I drop them? And I would like the stack to drop them for me. And if I do partial reliability, then it means that I have to have a stack that can cope with that. And basically my contention is the current state of SCTP is that it doesn't really. But like, I'm hoping to fix that. You don't entirely agree. We'll discuss it.
Okay, we have Lorenzo, and then
first of all, I don't know if you know that Iñaki is working on an SCTP stack as well, so he might be a person to talk to for the L4S stuff. Just in case you need help on that part, he is actively working on a new SCTP stack for MediaSoup right now, so that may be...
Okay, that would be super interesting to like collaborate on.
Yeah, and then another note, which is more like a curiosity. So you mentioned that the LIDAR data is more or less 2 megabits. Have you checked if there is there any compression that exists that would allow you to reduce the amount of actual data that you would need to send in real time for that?
Maybe. I've thought about the compression. The problem is all of the good compression algorithms want more data. Like compressing a kilobyte packet down to 750 bytes doesn't actually win you a lot because it's still a packet. Like you still have to send a whole packet. Unless you can coalesce a bunch of packets together, like 10 or 20 packets. So you like coalesce that much into and then compress that much data into like half as many packets or something. And then maybe you win, but you end up adding latency. It feels to me like there's a trade-off between latency and compression. Like the bigger the thing you have, the bigger the kind of piece of data you're looking at, the better you can compress it. And a lot of the compression, a lot of the easy compression is frame to frame. So that's the other question, is like whether it's worth trying to see whether the last frame is like the current one and not sending it if it is. I haven't even looked at like whether that, I don't know how much jitter there is, I don't know how accurately I'd have to like do that. I also don't know whether the rotational speed is completely constant. So like there's a bunch of stuff I haven't even looked at for that. So yeah, I think there is some possibility, but I think until I've got a reliable an unreliable transport to run it over, it kind of doesn't matter, because when we hit those dips, I'm never going to make that change fast enough, I don't think. Maybe, I don't know, it's still work in progress.
okay, thank you, Tim. Then, and yeah, he will be around or tomorrow.
Yeah.
And we have